Today we are looking into Python concepts needed for solving Leetcode questions. Python is known for its simplicity and readability. Its clean syntax allows you to express complex ideas in just a few lines of code, making it ideal for solving algorithmic problems under time pressure. Welcome back to LeetJourney. Now let's dive into some must-know Python that will help you tackle Leetcode problems with confidence. Python is a powerful language because it's dynamically typed. What does it mean? Dynamically typed allows you to create variables without assigning any type to them. So let's say I want to create a variable n with a value 13. And now I want to reuse this variable and assign it a string. This is perfectly fine in Python. Python allows multiple assignments at the same time. What this means is that you can create new variables and assign values to them straight away. So for example, in this case, we assign the value 1 to the variable n and the value abc to the variable m. There are different ways to increment counter in Python. So one of them is the typical n equal to n plus 1. The second one is to do n plus equal 1. You might be wondering, can we do n++? So this is not possible in Python. As you can see, it's also giving an error. So these are some of the built-in types that Python provides. So we can have strings, we have integers, and we have floats. We also have none, which represents the value null. We have true and false, which are the Boolean values. In Python, we also have some other powerful data structures, which are going to be really useful when you're going to be solving Leetcode questions. So the first one is Python lists. These are basically arrays. And here we can see how to initialize and declare a list in Python. The second one are dictionaries. These are basically hash maps. So here on the left hand side, you have the key, one, and then you have the value. These are extremely useful in any kind of technical interview. We also have sets. So as you can see, to declare a set, you just need to put the values in between curly braces. And then we have tuples as well. So these are immutable arrays. And to create a tuple, you simply put your values inside round parentheses. Let's move on to some operations which you can execute in Python. So if you want to execute logical AND, we can simply use the keyword AND, and this is going to evaluate X and Y. And if we want to do a logical OR, we can use the keyword OR. There are also other operations which are quite useful during interviews. So the first one is mod. So for example, if we do 3 mod 2, we're gonna get 1 back. If we want to do division, we can simply use the division symbol. In this case, as you can see, the integer division is going to return a float 1.5. And if you want to round this down, you will have to use double slashes. And for power, this is basically equal to 2 power of 3. So this is a typo. So this is 2 power of 3. There are also other ways of having some kind of logical operations. So for example, if this condition is going to be true, we're going to return X, otherwise we're going to return Y. So this is quite useful when you want to shorten your code. Another thing you have to remember is when you have double equals, what we are doing is we're comparing the values and not the references. So here we're actually checking is A equal to B. So we're not doing an assignment. So if we were doing A equals to B, this meant that A is going to be equal to the value of B. But here we're checking is A equal to B. If we want to compare the memory location, we can use is, but this is very uncommon during Leetcode questions. Let's look at this syntax here. So it might be useful in some cases, so I'm just gonna show it. So what this does, this any keyword does is, it's going to return true if any of these values is going to be true, and false otherwise. And in this case, this keyword all is going to return true only if all the values in this list are true. Otherwise, it's going to return false. I think we can try and run this. Let's see what happens. As you can see, this returns true. And now if we run this other one, this has returned false as expected. This syntax here infinity and minus infinity is quite useful when you're solving some problems, and you can simply declare it using this syntax here: float open apices inf or minus inf, depending on what you need. Let's look at loops now. So this is the first example. What we're doing in this case is going from 0 to 9 and then printing all the values in between. So as you can see, if we run this code, we get the value all the way from 0 to 9 printed. There are multiple variations of these for loops. So for example, here, what is gonna happen is it's going to print all the numbers from 40 all the way to this second number 50 minus 1. So if we run this, as you can see, as expected, it went from 40 to 49. We can also have an incrementer. So in this case, we're going to print all the numbers starting at 30, going all the way to 40 minus 1, and we're going to increment by 3. So if we run this, as you see, we are printing these 4 numbers. Okay, so let's look at this code here. This syntax here is used to iterate backwards. So in this case, we're gonna iterate from whatever n is all the way to 0. So for example, let's have n equals 10. And let's see what happens when we run this code. As you can see, it has printed all the numbers from n minus 1, which is 9, all the way to 0. There is also another elegant way to iterate through a list. So for example, here we can see that we're doing 4x in this list. So what this is going to do is this x is going to be assigned each value that is appearing in this list. So let's try to run it. As you can see, A, B, and C. And finally, we have the while loop. This is a very simple syntax. So while some condition is true, we keep doing the operations over here. Usually you have a decrement or increment step, whatever is applicable depending on this condition, because we don't want to end up in an infinite loop. So we need an increment or some kind of operation to actually break out of this while loop. Python provides a very powerful concept called list comprehension. So let's look at this example here. We have a for loop. So for n, that is going to assume each value between 0 and 5 minus 1. We're going to get each of that number and then running this operation, multiplying it by 2. And then we're going to form a list where we're going to concatenate each result. So if we run this piece of code, as you can see here on the right hand side, we have created a list x which contains all the values we expected. We can do more powerful things as well. So for example, we could create a 2D matrix. So if we run this piece of code, as you can see, we have created this list that we were actually expecting to get created. So you can get really creative. There are many powerful things you can do with list comprehension. I'm just going to leave some more examples here and you can have a look in your own time. Just pause the video. There is also another powerful concept called generator comprehension. So this is quite rare that is going to appear in your coding interviews, but I still wanna show it to you briefly. So let's say we have this piece of code and we are doing a bunch of operations. So basically, we are getting all the numbers up until a number n, and then we're checking if it's an even number. If it is, we use this operation yield, and then this is going to create a generator of events number. But all of this can be done using this simple line of code. So let's see what happens when we run this. Basically, we have a generator that is going to return us even numbers. So now we can use this generator to generate even numbers. As you can see, if we run the next method on the generator, we're going to get even numbers generated. So let me run it one more time as well, and one more. So as you can see, it has generated even numbers, and this was quite easy and simple to do. So in Python, we can have functions. This is how we define a function. Basically, we use the def keyword, and then we can define a function and do stuff in here. Another concept you should remember is typecasting. let's look at this example. We have a list. Let's say we want to convert it to a set. We can simply pass the list as variable to this method set. The same is valid for a tuple or a list. So in this case, we have this list that is first going to be converted into a set, then into a tuple, and then into a list again. So let's quickly run this. As you can see, we have our set, we have our final list, and we have our initial list and our tuple as well. There are also other operations. So for example, let's say we have this integer and we want to convert it to a string. We can simply use str and pass in the number, and then we can convert it back to an integer again using the int method. In Python, you might come across classes. You might have to declare a new class when solving a Leetcode question. So the keyword you have to use to define a class is class. And then for the constructor, this is the name of the constructor method. So def _init _ again. And then you need to remember this keyword self. And here you can have all the attributes you need for your class. You need to remember that when you have functions inside a class, they require this self keyword. And here is an example of how you can create an instance of your class. And then you can use the object you have created, dot the name of the methods you have created inside your class definition. So let's look at strings now. So we can define a string using either single quotes or double quotes. It doesn't really matter. And in this case, we can see here that strings can be treated as lists. So let's say I wanted back the letter at position 2. This is going to give back the letter C. So let's try to run this. If we try to print y at position 2, this is going to return C, which is what we are expecting, and it is returning C. We can also concatenate strings using the plus sign, and we can also iterate through strings as if they were lists basically, and we can use a for loop. So this for loop is going to go through each letter of the string y. A very powerful data structure available in Python is the list data structure. It's basically the same as arrays. Let's look at this example. So we have a list of integer. This operation here, 5 in x, is going to return a boolean, and this operation is going to take big O of n time because we will have to iterate through each element of this list. To iterate and print each element of a list, you can use a for loop, and then you can do for each element in your list. You can print it. It's quite simple. So what this does is if x is not empty, it's going to run whatever is here. We can access an element of the list using indices. So in this case, if we put 2, this is going to return the value at index 2. And you can also have different kind of elements in the same list, so different types. So if we run this, we can see that x is made up of integers, and we also have a character as well. We also have some other useful operations such as pop and append. So let's try to run pop. Let's see what happens. So pop is going to remove the last element of the array, and append can be used to add an element at the end of the array. So the time complexity of the list data structure is big O of 1 for reads, because we can use direct access using an index. To add and remove instead is big O of n. Let's look at some list operations that can be run on lists in Python. So we can concatenate a list using a plus. You can duplicate a list as many times as you want using the multiply function. So when you have -1, this is going to return the last element of your list. So this is quite useful when working with stacks, for example. You can also apply slicing operations to lists. So in this case, this index here is gonna print everything starting at index 3 all the way to the end. And here is a bunch of other examples which you can try and run in a Python interpreter, and they're gonna be clearer as well. Here are some other operations that might be useful. We can use the reversed method to create a reversed array of x. X is a list. We can reverse the list itself in place using the reverse method. We can return a sorted array of a given x, and then we can also sort our array in place using the sort method. So these two are the ones you will actually need, x.reverse and x.sort. So these are the most common ones. Let's look at this example. Let's run sorted. So this is going to create a new array. As you can see, we have a new array, and instead if we create an array and then apply .sort, this is going to sort the array in place. As you can see, the array is already sorted. Search in a sorted list takes log n time, because you can apply binary search. Adding and removing is going to take big O of n time, because we will need to iterate through the list and find the correct place where we want to add or remove. And to create a sorted array, to sort an array, basically, we're going to use a sorting algorithm. So that's going to take big O of n times log n time. Let's look at another data structure, which is the doubly linked list. In Python, you can create a doubly linked list using the Deque import, which is from the collections. So this is the data structure that represents double-ended queue. Here is an example of how you can create one. Let's look at some more operations as well. So for example, with this syntax here, we can check whether the number 5 is in our Deque. This is going to return true because 5 is here, but this is going to take big O of n time. We can also iterate through each element using a for loop. We can also access elements in the Deque using the index. But we still need to remember that these are going to be big O of n time. So these are not going to be constant because basically it's a linked list. So we have to iterate through each element to reach the one we actually need. Here are some other useful operations that you can run on a Deque. So for example, pop is going to remove the last element of the Deque. Pop left is going to return the first element of the Deque. And these Deques are also used to create queues in Python as well. And using the append method, you can also decide whether to append at the end or at the beginning of the Deque. Hash maps are another important data structure which is fundamental to solve Leetcode questions and to pass technical interviews. Let's take a look at them. So to create an empty hash map, you can just create an empty dictionary. Here is an example of how you can create and initialize a hash map with keys and values. So for example, here we have a key, which is a string, and we have a key, which is also an integer. This is perfectly valid in Python. In fact, if we run this, we can see that we have 3 elements created with corresponding values. So these are the different ways of creating a hash set. Let's look at some operations that can be run. So if you want to check whether a key is in the hash map, you can simply use this syntax. Name of the key, in keyword, and then use the name of the hash map. You can also iterate through each key of the hash map using for key in the hash map. You can access keys directly using this syntax over here. This way of getting values from the hash map is actually quite useful during some Leetcode questions. We want to get the value with the key 15, but if it doesn't exist, we want to return a default value. So in this case is 0. The time complexity to read and add or remove from the hash map is big O of 1. So they're very efficient. Another powerful data structure which you are going to come across quite frequently are sets. So here is the example of how you can create an empty set using the set method, and then you can use curly braces to initialize and create a set if you need one. Similar to hash maps, this is quite similar. You can just use the for loop to iterate through each element of the set. And you also need to remember that set cannot have duplicate elements in them. Some useful operations are add, remove, and pop. Read and remove time complexity in this case again are big O of 1. So it's very efficient. Stacks in Python can be implemented using a list. So as you can see here, we have declared a stack. If you use the pop method, what this is going to do is it's going to pop the last element of our list. So in this case, it was 5. As you can see, 5 is not here anymore. And if we append, this is going to append at the end of our stack. Let's say 10. As you can see, this has been appended to the end. A read is big O of 1. Adding a removal is big O of 1 as well. So as I told you earlier, a queue can be implemented using a Deque. We can use the append method to add to the end of the queue, and then we're going to use pop left to pop the first element in the queue. So let's run this code. So we have created our queue. Now I'm going to append something to our queue, let's say 24. As you can see, it has been appended to the end. Now let's say I want to get the first element of the queue. I'm just going to do pop left. And this has popped the first element, which was 5, and returned it. So this is quite useful when solving queue-related problems. Another useful data structure is heap. So a heap stores the smallest element on top. And you also need to remember that Python only allows min heaps. So if you wanted a max heap, you will need to negate all your values when you push and pop. But let's look at this example. So you need to import heap queue. And let's say you have a list of integers and you want to heapify this. There is a method in heap queue which is called heapify. This is going to turn your input list into a valid min heap. And then you can use heap pop and heap push to either pop the minimum or to push a new element to your heap. So let's try to run this. We have created a list. Now we want to heapify this. Let's see what happens. As you see, it has changed the value. Now when you're going to run heap queue pop, this has popped the minimum element, which was 1. And now if we try to push 3, this has added 3 in the right place. So reading from the heap takes big O of 1 because we always want the smallest, and we know the smallest is going to be at index 0. To add and remove is going to be big O of log n. And there you have it, a crash course on must-know Python for Leetcode coding interviews. Make sure to spend plenty of time improving your skills on Leetcode and other coding platforms. Thanks for watching and happy coding. I hope you enjoyed the video and found it somewhat useful to reach your goal. Please don't forget to like and subscribe, as it allows me to keep creating more and better content for you, all completely free of charge. See you on the next video.